So you may have seen recently where Black Pen, Red Pen posed the question, what is the floor of 0.99999, etc., with 3 dots on to infinity? Is it 0 or is it 1? And a lot of people thought it was 0, and a lot of people thought it was 1, and he's got a video where he answers that question. And you'll get my 2 cents worth towards the end of this video, but first I want to ask a similar question. And that question is this. Let us define a function, f of x, for all real x, where f of x is x squared, except when x equals 2, at which time f of x is negative 1729.3. Here's what that looks like. It looks almost like f of x equals x squared, but there's that little tiny hole, and I didn't even have room to put the f of 2 because it would be off the charts here. Okay. So now the question for you is, what is the limit as x approaches 2? Is it 4 or is it negative 1729.3? And first of all, we will look at the ant definition of the limit. Okay, so imagine a very tiny itty bitty ant, okay, crawling up that function. And it's so tiny that as far as this ant is concerned, it's crawling up the y equals 2x line. And it has no indication that the bridge is out. And it can get as close to x equals 2 as we want it to before it knows anything. This ant has every reason to believe that when it gets to x equals 2, the function is going to equal 4. And the same goes for an ant going downhill. It has every reason to believe that as x gets closer and closer to 2 from the top, f of x is going to equal 4. So this is the ant definition of the limit. It asks, what is the function doing really close to x equals 2? And then we get into a more rigorous definition, which we'll touch on here. This is your epsilon delta definition. So what do we mean by close as we like to 4? What we're saying, we can make f of x as close as we like to 4 by choosing some number to plug into it close enough to 2. Okay? And as close as we like to 4, we use the epsilon to talk about the distance from the limit, the distance from 4. And epsilon can be as tiny as we like, but epsilon cannot be 0. So when we say, oh, how close do you want to be to 4? You can't say, well, I want to be right on top of it. Because epsilon has got to be greater than 0. It's got to be positive. But otherwise, the sky's the limit. Or just the opposite. Never forget what I said about limits. Okay, so here in this diagram, you can see there's epsilon. And epsilon, that can squeeze as tiny as we like. It just can't be 0. Okay? And then over here, now we can see that that matches with some distance from 2. And that distance is what we call delta. And now you'll notice that on either side of that epsilon, those vertical lines, they're different distances from 2. Okay? So my question for you is, which of these is the real delta and which of these is the fake? Okay? And you post your opinions down there in Commentville. Okay? So this formalizes a little bit what we mean by we can get as close to 4 as we like by picking a number close enough to 2. Now, where does that bring us with the 0.99999 ... Okay? What we mean by that equaling 1, okay, is we mean we can make that number as close to 1 as we like just by adding more 9s. And yes, this is a plot by Big Math to sell us more 9s. What do we mean when we say that this number approaches 1 as we stack on 9s? Because it also approaches 2. It's getting closer and closer to 2 as well. It's getting closer and closer to 1729. Okay? But there is only one number, and that's 1, that we can say that we can get as close to as we like, arbitrarily close, by adding another 9. So when we say that the floor of 0.999, and there's a limited number of 9s, when we say the floor of that is 0, what we're saying is we're trying to climb up these 9s and get as close as we can to 1, but then we stop at some defined spot. And so then we fall down and we're at 0. Okay? But what we mean when we say that the floor of 0.99 with all the dots is 1 is we're saying there's no distinction between this number and 1. We have an unlimited supply of 9s. And you can keep on going on. You're going, we're getting closer and closer to 1. This is a way to represent the number 1. How close do you want to get to 1? We've got the 9s for it. The only thing is you can't say, I want to be right on top of 1, because epsilon can't be 0. If that sounds like a bit of a finagly cheat to you, well, it is. Okay? This was something that they invented to make people hate calculus. And it works. So I think that's the subscribe there. And there's videos there. Bob's your uncle.